No one has joined till now. Let me wait for a few minutes, then start. Okay, am I audible?
Yes.
Okay, so let me share that screen first. And do you have any problem on 15th April?
If there is holiday, then no problem.
There is
Otherwise,
holiday because holiday means in Bengal it's holiday, uh, but I don't mean general, but it's holiday.
if Bengal, then okay, no problem. Then my college
Because
also should off.
because I have to select a date before 16th, and because the last class, our last class will be in the next week, that is on 13th. So we have only 3 days, 14, 15, or 16. That's why I choose 15. 16th I am returning, so that's why 15th I can, and that will be extra session type. In that class, we can discuss the total course, if we have any doubt from entire course, anything that we can discuss, and those topics which I have said, Joule-Thomson coefficient, and that gives Helmholtz equation. That two parts that probably I can do in the next class or in the last class also. That I will see, but that obviously we will do. And today I will mainly solve some practice problem. Okay. And the equilibrium part. That equilibrium part, we have not covered anything. So a few problems, so I will try to cover. Then more or less this will be completed, I think. Yes. And if you have any specific doubts from the assignment question or any other things, then you can ask me, especially for the special class, because that will be also a 2 hour class. So I have to prepare that much content. Okay.
Okay.
And also, if you have any other things to discuss, that also you can ask me related to thermodynamics, but that's not restricted to this course. That you can also ask me. Okay. So let me
Okay.
now share this a video screen. Let me check whether it is going on record. Yes, it is going on. Okay, is it visible?
Yes.
Okay. So in last class, we were discussing a problem and we stuck there, right? Do you have tried that Van der Waals gas problem,
Yes.
something like that? Do you have tried to solve that one? Because what I found, they are assuming while solving this type of question, they are assuming um, they are assuming, not assuming, they are actually writing this z equals to 1 plus these things they are writing. So if you consider this formula, then you can easily solve that problem. But uh especially we have to prove this. Okay, let me try. I don't know, maybe there is some assumptions I'm missing, but it's not straightforward. Okay, okay, you also try to prove it. But for van der Waals gas, this is the formula actually. Z, the original formula of Z, that is V real by V ideal. Okay.
Yes.
Hmm. So now, according to this formula, we have to solve it. Now, let me try it. If it is not gone well, then we'll consider this and we'll solve the problem. And I have to find out the derivation or proof. Okay. Just what was the van der Waals equation? P plus A by V square for 1 mole of gas. Because if you remember,
V minus B equals to RT.
RT for fugacity, everything was for 1 mole. So this P and V, what is this P and V? This P and this P, whether it is real or ideal.
Van der Waals real.
Real. PV equals to nRT or VV equals to RT. Here, this P and V are real, ideal. So let me give a tag here. Ideal, ideal, RT. Now, when you are considering the van der Waals or the real gas, then essentially we have to, if you remember the proof of the van der Waals gas, the logic behind the this correction, this was the correction factor, right? So essentially, we have to subtract a volume V. Why we have subtracted? Let us consider this part. How does it come? It's actually V times V minus NV. Because if you remember, if there is a gas,
Molecule also has volume.
molecule also occupy some amount of volume. So V is the volume per molecule and N is the number of molecule. That's why it's V minus NV. Okay. So if if molecule does not have any volume, then V tends to 0. Correct?
Yes.
That means it essentially goes to V. So that means this is the ideal. Do you get it?
This V minus NB.
Not V. V is the ideal, and you are subtracting that NB, means total volume occupied by the molecules. Then you are getting the real volume. So you can write it V real is equal to V minus NB. This V is not the real volume. This is the ideal volume. Do you get the logic?
Yes. Yes.
Okay. So essentially, this P and this V are essentially ideal. So what you can write, because ultimately what we are doing, this P real and V real equals to RT, we are trying to modify this real part in terms of ideal parts. That's why. So essentially, we can write P ideal plus A by V square times V ideal minus 1. In pressure correction also, this is the pressure which is given by the ideal. If there was no interaction among the molecule, then this amount of pressure would have been given in the walls by the gas molecules. But there is a by V square, where A is signifies the attraction between the
Attraction
molecules.
force between the molecules.
Molecules. So that means uh, you have to give more pressure, right? Just you have to think like that.
Yes.
Let's say the same. Okay. So if there is no attraction, then A tends to 0, then that pressure will be P ideal. It's clear. Okay. So now if there is a P ideal, if there was no attraction, but due to attraction, what will happen? That there will be some uh, attractive force between the molecules, right?
Yes.
I think this was the logic, if I'm not wrong. And that's why you have to add some amount of pressure so that the same force would have been given in the molecule if there was no interaction. Okay.
In real, the pressure should be less than the ideal.
In real, pressure should be less than the ideal. Yes, 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 yes. Mm, that means you are saying, okay, this part I have to also think. That's why I want to discuss. Yes, that means you are saying this is real. This is P real. That's why you are adding some amount of pressure, A by V square. That's so that you can get the ideal pressure like that.
Yes,
Okay, okay, okay,
because one molecule is attracting one molecule, then it will apply less force to the wall.
But in case of V, whether that is ideal or real, you have to subtract that volume. If I subtract
Then
that
it's real.
real volume to subtract that volume, then it is actually you are saying then it is the ideal volume like that.
Yes,
Okay, let us consider both are real, then we'll see what will happen. Okay, P is real, that is sure. But this V part, because this argument is also correct. So there was two way of thinking actually. But for the time being, let us not consider this. We are considering both are V real. So if this is the case, so from here, whether this V is ideal or real, because everything is real, so it should be the real. So we are giving specifically tags, whether it is real or ideal, so that we can distinguish. Now Z is this
V real by V ideal.
this P should be ideal,
Yes,
correct? Because V ideal should be equals to P ideal by RT. There is no doubt. So this should be P ideal. So what is P ideal here? Then you have to write the P ideal, na? Then you can put. So let me.
yes,
So there is a catch. Here is the main doubt, and you have to apply some approximation so that you can consider the P ideal part. Then you can do. I think this approximation is important. That's why that form is not coming. But let me try. So how you can consider the ideal pressure? This P real is RT. This this is the real pressure, not the ideal one. So if we have to consider the ideal pressure, then what can we write? That is the important factor. Ideal pressure. That we have to put there and automatically we can get it, right? That's our uh, target. So
yes,
from this equation, I was also trying, but I did not figure it out. Uh, so let me try here. If we can, then it's okay. If we ultimately we have to prove this equation. Z is that means this is V real by V ideal. That means P ideal V real by RT. This equation we have to prove. Or if we want to simplify this equation, then you can write it P ideal V real equals to RT plus P times B minus A by RT. This equation we have to prove. So let us do back
Yes.
calculation. What appears, let's say. So this we obtain. Then we will solve. What assumptions is making, that is important to find out. There must be some assumption. So this, right?
Some part will be negligible.
That's why, because from this P real you have to write down the form of P ideal, right? Then only you can put na
Yes.
here. You have to put a mapping between P real and P ideal, then you can do it. Okay. And what is this P R P P P लिखा है? Okay, this P is obviously P real should be. So it is P real. Mm. Just see there is a mapping between P ideal to P real. That is needed actually.
Which one is greater, P real or P ideal?
You have already stated that.
Yes, so there should not be any confusion.
But you need a equation. Do you get it? There must be a equation, na?
P ideal equal to P real plus A by V square.
Uh, Say it again.
P ideal equal to P real plus A by V square.
Let us check whether it is coming or not. So PR is there. So PR form we know. PR is R by VR minus V. No, from here you can directly write it. Okay. This part V real. So V real. Okay, you are assuming like that. No, that should not be straightforward, not essentially. So you have P ideal. Hmm. So this is the P ideal. You see? So if you want to take common PR, then it will be if PR plus something if you want to. So if you simplify RT by V by R plus, so I could you thought this, but here we are getting something this. Hmm.
B by VR is negligible in the second term.
That approximation, if you allow, then we can do anything, right? If you allow to do that,
It is correct because B is very very small compared to VR.
hmm. Okay. So, okay, let's take these definitions. You have said, na, this is the ideal. So let us take that definition. Then we can do it. Let us check whether we can do it or not. according to you, let's say this is P ideal, it's a good point. So if it is P ideal, then Z will be obviously P real VR by RT plus AVR by RT VR square. So you can write it. So this is the Z, correct? If I put
Yes.
P ideal here. Okay. So what we can write here. So Z is this. So PR is this one. So now we have to just put, we have to just calculate the Z. So Z is PR we know already. So just put PR equals to RT VR minus V A by VR square. Then VR by RT. So it is VR plus B minus A VR RT. Essentially, it is VR by VR minus V. It should be. You see what is happening when you consider this as P ideal, automatically V ideal becomes V real minus V.
Yes.
So Z becomes this. Okay. So this is not that much straightforward. There, this is not P ideal actually, because when you are, we have to consider P ideal, then obviously you have to consider the role of volume as well, not only the pressure. So from the let us expand this equation, then probably we can get some idea. If we expand the van der Waals gas equation, then we will have P first terms. Let me write it again. Okay, well, I will try to prove it. If I can, then I will share it. Let us try last time. Then, considering those formula, we will solve that problem. Otherwise, it will take say time. It just you are seeing just a approximation that is needed here. If you know this, then easily you can do it. So let us do it. Hmm. This is the Z, and this Z is written here as this form. So PR one is there, so one must be one. Next, another term is PRB by RT. That we have already option, I think. No, PRB by RT. Leave it. I don't know. Okay, I will try it. Okay, you can also try. Okay, if you can do it, then you can share me. I will also try. Okay, but ultimately you have to solve that formula.
What is the main question?
A numerical question, right? We are trying to solve. We were trying to calculate the fugacity. If you remember in last class, what was the question? This question we are trying to solve, right? A, B coefficients are given and we have to calculate the fugacity. And for calculating fugacity, we have to know the Z. That is the important part. The thing is that if you know Z, then you can calculate it easily. So let me copy this question and we'll solve it. Okay. So this question we have to solve, and how you can solve it? Try to solve it considering J above formula, this formula, right? I think it's easy. If you consider that formula, then it is doable,
Yes.
right? Then I What is the answer?
I am calculating the last part.
Okay, let me start this. Do it. I'm also doing. Okay, so we have calculated the fugacity. The fugacity was defined as phi times p, and this phi was defined
E to
like
the
p
power
into.
0 to integration 0 to p z minus 1 by p dp.
Okay, so now Z is given. So this integration we have to do. Then we can evaluate the form of f, and then we can put the values and we will get the answer. What? So this integration is our first target now. Let's say dp. This is a dummy variable actually. That's right. Now z is given as 1 plus
V minus a by rt into p by rt.
z minus 1 is from here you can write pb by rt Correct? P will not be there because that was divided by P.
dp by yes
How this can be? Ah,
bp
galat
by
hai.
rt minus
If
a by
there
rt
is
square
what
a by rt whole square.
at a, that's okay. A by RT whole square, you are correct. R square T square. But if there is no P, then this integration will be zero. There must be a P, right?
Why?
You are doing integration over P. Okay, you are saying integration of dq will give a P. But this part will
Yes,
remain as constant. Okay, you can bring it out at constant, and this part will give you P. So this is our the integrating result up. We have to do it exponential, right? Let's say so we have to
yes,
do it. So f is exponential was there, right?
yes,
So exponential of pb by rt minus ap by r square t square. This is times p, because this was the fugacity coefficient we were calculating. There was a p. Not, so now we can essentially calculate this. Do it. So p is given as
300 atm.
300 atm, correct? 300 atm. And essentially this will be the number. So unit is very clear, atm. And exponential of pb by rt. So p is 300. B. What is B? B is given 0.0266 divided by RT. T. Okay, it's important.
0.082.
Why?
Why?
The unit of R. How we can decide B has the unit. This unit is decimeter.
Liter.
Oh, sorry. This unit is decimeter cube. Decimeter cube
This in liter atmosphere. So the under part also in liter atmosphere.
mole inverse. Correct.
Yes.
This is the unit. So you have to take the unit of R. So decimeter cube, you know, this is the liter.
Yes, and the pressure is given in atm.
ATM. So it should be then liter ATM. So that is 0.082, and the temperature is 373. Correct.
Yes.
Oh, now A. A is given a okay decimeter cube. Okay, then everything is correct. Means there is nothing to do with the unit conversion. This also 300 ATM and R square T square. That means you have to just square this. Now what is the result? First solve this part. What is the result of this? Let me also do. What is the calculator? Don't know.
0.3564.
I am getting 0.2609. only from the first part. This is, check it. That is 0.0266.
Okay, sorry, I am getting the same.
Mm, mm. And the next one, do it correctly. I am also doing it. Then we can check.
Zero point zero 0.0782.
Mm, correct.
Yes.
0.0782. So you have to then the final value will be this. So it is 300 times exponential of 0.1827. So it is
1.2.
one. Let me do it. 1 point. So it is final value
360.
360. So see, this is the fugacity. Okay. So fugacity is the
Yes.
actual pressure. So from Van der Waals equation, you can't say it like this, that that's the P plus A by V square. That is not the actual real pressure. Real pressure is the fugacity. Okay. That you can say the Van der Waals pressure or Van der Waals volume. Okay.
In fugacity, the intermolecular attraction is considered or not?
Consider. Consider.
What is the exceptional thing about it? That means it is the correct and not the A1, that intermolecular attraction P plus A by V
No, that
square.
uh, um no, because this fugacity definition is general definition. That is not depends on, you see, whether that is Van der Waals gas or anything. This is the general definition. You are assuming the gas is Van der Waals, and from that assumption, you are getting an expression of Z. So then you are calculating. So that's why you can say this fugacity also for the Van der Waals gas. But that is a special case. But the equation is general.
For Van der Waals gas, both are correct. Van der Waals and this fugacity.
Yes.
Okay, that I was saying.
But the expression may not be same,
Why?
because you see, while calculating this Z, you are getting making some approximation now. Means what I am saying, you have this equation, let's say, this equation, right? But from here, what is the real pressure? Do you know?
P plus A by V square.
No, that is not real pressure, because you are thinking in your background, you are thinking that PV equals to RT. This formula is valid for the real gas as well. Maybe the form is not like this
It is worldwide true. PV equals to RT.
for ideal gas.
Yes.
For real gas, this is not necessarily be true. This linear form. Later, when you study this virial, I think gas, okay, then you can see this is not the linear. Just there are the square terms. These terms are there. Non-linear terms will appear. Okay, so
In the
this
virial equation.
virial equation appears now.
Yes.
Hmm. So that means that this Now what are you doing? You are just analogously saying if P equal to RT is for ideal gas, then analogously you can write it. But I'm saying, let's say for real gas, this equation would not be analogous. PDL, VDL equal to RT. Then you can write PDL plus 1 into VDL by R equals to RT. Then that may be na, or some, let's say P square by R something in R. Any form it can take. So it's not necessarily linear. So that analogy you can't bring here. Okay. So,
Okay.
but what you can write? P van der Waals. For simplicity, if you want to do
Yes.
simplicity, that you can write. That is a notation. That essentially does not mean that this is the real pressure.
P van der Waals, that is the fugacity.
No, fugacity is the real pressure. What I'm
It is for
saying,
real gas.
no, just understand. This is not that much tough. You are just confusing. Just understand it. Like from this equation, you don't know what is the real pressure. Correct?
Yes.
Why? Because this is just correction to pressure. But this volume
Yes.
correction will also lead some effect on the pressure, na?
Yes.
How you can ignore that? If you consider this as real pressure, then that correction will be ignored.
Yes.
So that's why. But when you calculate fugacity, you are calculating on the basis of Z. But in Z, both A and B has been uh, accumulated.
Yes.
So that's why for this is the fugacity or real pressure of the van der Waals gas, but using the total equation, not on partly equation. Okay,
Okay.
that's the reason.
So
We
for pressure it is fugacity and for volume,
okay, for volume also you can define something like that, but that is not important very much. Okay, because you see volume V minus NB is very small, and B you can calculate, but there is also volume effect in the pressure term as well. So you can obviously define, uh, but you see, just understand what is phi.
fugacity coefficient.
F by P, right?
Yes.
And from uh, knowing phi, you have calculated this F.
Yes.
Okay. Similarly, what is Z?
What is
Z.
compressibility factor?
So VR will be,
Yes.
from here you can calculate. You see that for volume also, uh, that so if you try to do analogy, then V ideal should be V ideal minus B, right? Something
Yes.
like that. But that is not. You have to multiply it with Z. This is the real volume. Okay. So which is
Z
the
is like the fugacity coefficient for
exactly
volume.
fugacity coefficient for the volume. Okay.
Okay.
So that's the reason. So that's why it is very general. You are calculating the real pressure in terms of the real volume. This is the real volume. Z times V is the real volume. Something. Okay.
Yes.
Okay. So that's why it's important. Okay. Let us do another question from this fugacity. Then we'll do something else.
What is the most accurate gas equation?
Till now, VDL. And then also any other gas equation are there. In Castellan, I think you will have a list various gas equation. But what happens? These equations actually uh, essentially does not fit with this plot. There is a plot now. If you plot pressure volume plot, then you will have this kind of plot. If I'm not wrong, something like that, right? No, 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 something like this.
Yes.
Uh, liquid, solid, volume, this type of, right? So this plot, I'm also wrong, I think. ऐसा कुछ था। आई एम नॉट करेक्ट टोटली, बट वैन डेर वाल्स gas, what it did, van der Waals gives this type of lots. Phase change. Phase change cannot be justified with this equation. That is the main reason. Okay. But yes, essentially there are lots of uh, gas equations. Even Meghna Shah probably has one.
There is in Castellan.
Castellan, I think I have seen the list. There is a list of the gas equations. Or you can Google it. What is the oh not coefficient. Do it. This is straightforward. You know the formula right now.
Yes.
Do it.
Is it related to the previous question?
Same formula will be used.
Okay, then I'm doing.
No, this is for Van der Waals gas. I have not written that, but this is for Van. And additional information are pressure is 100 bar and temperature is 25 degree. That is also given, right?
Yes.
But you need A, B, these things you need, correct? That is given in the
It is
previous
not same
question.
as the previous.
Yes, same as previous.
Can you please show the previous one?
Sure.
One ATM equals to 1.013 bar.
Yes. More or less. Huh? Yes. Let me do. So again, we have to calculate the coefficient, right?
Yes.
What it will give? This the integration we have done already, and that is this. Okay. Just calculate it. Nothing is there. So P is given as 100 bar. So 100 bar. 100. E is given as,
What is the answer?
what is your answer?
107.12.
Mhm. Match. Mhm, yeah. So B is 0 point. Let us calculate. RT.
0.082. 290. First one is 0.1102
Right? You can calculate that.
minus 0.413 something.
One thing you can multiply here. Here also in both cases. 1.0123. Correct?
Yes.
Do it now.
In the first one, BP by RT, I am getting 0.1102.
This one, right? Let me do 100 times 0.02. What are you getting?
I have calculated with the 1.013 factor.
Okay. I am getting this. And you are getting?
0.1102.
Okay, more or less same.
Multiplying by 1.013 giving this.
Mhm. 0.040.
Yes. Total exponential part is 1.071.
I'm getting
1.07122. I am also getting it.
then probably it's correct.
One 107.12.
Okay, then it's correct. I know why answer is not matching. Answer is given as 120.9 bar. Don't.
Okay, but I was getting that.
It's okay. Okay. Let me now find questions. Because now we'll solve varieties type of question. Okay. No, before that we'll solve some question from that equilibrium part. These
Okay,
questions are very easy because already you have done in class 11, 12. That's why I'll not do very much. Maximum 5, 6 question I will solve them. Okay. These are log. Wait, 10 ways. Plot or graph. Plot even.
Theta is tan inverse what?
0.12.
Del H naught is
Del H naught,
Del H naught value is
9 point.
9.574.
Exactly. Then
A is 10 to the power 10.
correct. Next,
K value is 9.95 into 10 to the power 9.
mm, yeah, almost done. So let me start.
Last is 9.98 into 10 to the power 9.
Excellent. First one, calculate del H 0. How you can calculate that?
From the slope.
You have this equation. Okay. And this plot is log k versus 1 by t. So, okay. This is very easy.
It is C minus mx.
Huh?
C minus mx
Why?
because the straight line is decreasing.
No. The equation is always y equal to mx plus c. Okay.
Okay, so slope is negative.
If m is negative, that means it's a uh, decreasing function. Okay.
Yes, I was saying that.
Hmm. That does not mean that there is that is minus mx plus c. That is not. See, minus appear here. This is our m. Correct. And this is, and we know tan theta,
Yes.
and that is
0.5.
0.5 because theta was, so what you can write here. So from here you can think that, okay, so the negative sign is appearing, right?
Yes.
So how you can argue that?
The reaction is exothermic.
So negative sign is essentially means that, okay. So but
Okay.
okay, but in your answer you did not mention there is a negative sign.
Yes.
So essentially there must be a negative sign. Now theta is tan inverse 0.5 is correct. Theta is, everything is correct. So if you put it, then del H 0 or not, that will be this. What will be the answer? Am I correct? So it is 8.314. So it is actually minus 9.35. What will be the unit? Unit of,
Joule,
units of R. Joule per
Kelvin, mole inverse,
mole inverse per
Kelvin.
Kelvin. This is del H naught. Okay, now the second question was uh, A. How you can calculate A?
With the intercept value.
Intercept value. What is the intercept value? That is log A. So now B. This is, so A will be 10 to the power C. So what, and C is actually the length of OP. This is the intercept, correct?
Yes.
And that is given, what is given? 10. So it's straightforward, 10 to the power 10. Now C. C is, sorry. C is, we have to calculate the K. So if you know these all things, then you can easily calculate. So let me calculate. Log K will be, this is 10 intercept minus delta H naught. So delta H naught is negative, but that is not needed because aim you know. Aim is just 0.5,
Yes.
correct? So aim you know and X you know. So that you can put. So it is just mx. M is 0.5 and it is 1 by t. This is, hmm. Okay, no. You see, there was a problem.
What?
Let- This is theta, correct?
Yes.
But here this was said as theta. So this should be the angle which is 180-degree minus theta. Got it?
Yes.
So here essentially M should be tan phi minus theta. Okay?
Yes.
And tan pi minus theta is minus tan theta. Correct?
Minus 10 theta.
You you know now how to calculate this?
Yes.
It is minus tan theta, I'm not right. This all sine and cos. This rule you know, I think.
Yes.
So here only sine is positive. So this you can write as minus tan theta. So the minus sign will go away and then it will be plus. That's why your answer was matched accidentally.
But in my book, there is given on that way in my style.
Your book.
That means the book I read.
Okay. But that should not be, you see. Essentially the result is same.
Why? For negative slope, it's minus mx plus c.
No, then you are changing these things. You are changing the definition. When you write y is equal to minus mx plus c for negative slope, then this is the theta. You are changing the definition, okay? So
Okay.
not to do that. Why you memorize two different kinds of definition? Just stick on that. Stick one definition, and if it is negative, then minus sign you will just put the minus sign. Okay, always follow a generalized definition.
Theta is the angle with the x-axis in the positive direction.
Always that slope means that. Why this is tan A? Because when it is very small, let's say, then if this theta will always remain same, na? Let's say if this distance is very small, then it is dx, and if it is dy.
dy.
Then you can write tan theta equals to
dy by dx.
dy by dx, and dy by dx is the slope. Okay, that's why the tan theta we can write tan theta as slope. That's the reason, na? So you have to consider that only. So your approach is not wrong, but then you have to remind another one when the slope is negative, everything you are just multiplying with minus and you are memorizing these things. Why? Hmm. Not necessary, right?
Okay.
So it is. So here slope is okay. So these values are already known. So put better to put that del is 0 because minus del is 0 by 0. Now calculate it.
Nine 9.9983. The total answer.
Hmm. But it should be there, right? Let me see it. Therefore, k is 10 to the power
9.96 into 10 to the power 9.
next. This was our C. And the last question D. We have to calculate the K in for a different temperature. So K1, let's say, this was our definition.
Log K2 by K1 equals to del H naught by 2.303 R into 1 by T1 minus 1 by T2. 1 by T2 minus 1 by T1.
So from here you can do it. So we have to calculate the K2. So if you change it, K2 by K1, then it is T1 minus T2. Okay. Now we have to calculate it. K1 is given, but this factor we have to calculate. Del H is T1 and T2. T1 is 298, T2 is asked to calculate 900 Kelvin. And K1 we have already calculated 9.96 into 10 to the power 9. So what will be the answer? Let's solve the power is uh
10 to the power 0.001122.
okay, 10 to the power 0.001122, right?
Yes.
Essentially it is
1.0025.
You have to multiply it with 9.96. You are getting.
9.98 into 10 to the power 9.
So you see, you change the temperature from 298 Kelvin to 900 Kelvin, and due to this huge change, the rate constant eventually does not change, right?
It is in 10 to the power 9 format.
Hmm.
It is in 10 to the power 9 format.
So what?
So the change is huge.
No, change is not huge. When you are saying change, that essentially does not mean K2 minus K1. How many times it changed?
Okay.
Okay, that's the important factor. Why? Because temperature is in the normal form and K is in the log form.
Yes, logarithm form.
That's why this happens. Means if you uh, change 10 times in the 100 times in temperature, then 2 times will be in the K something. So,
Yes.
this is not 100 times change, correct?
Yes.
Okay. So next question is, this is I think quite interesting. I have not solved it. Let me try. You try first, then I will solve. I will also try. Calculate delta G. Okay. Standard free energy of glucose, CO2, H2O, these are given.
It is in per mole.
Joule per mole. Oh no, sorry, kilojoule per mole. Okay, kilojoule per mole.
Okay.
So we have to check whether this reaction is feasible or not.
It is obviously feasible.
You have to prove it. You have to check it. Just you have to calculate del G.
Del G is negative
What is the value?
minus 2579.1.
Check it. Maybe you are correct. Don't know. You have to calculate the LG, right? And these standard free energy, Gibbs energy are given. So just del G will be G product minus the reactant. Okay. So what are the products? CO2 and H2O. And for reactant, oxygen is not given. Right? I think that
It
is
is
wrong.
pure element.
Hmm. So it will be
Zero.
correct. You have also done the same.
Minus 3489.6 minus 910.5.
Hmm.
So the total answer is minus 2579.1.
But I am getting minus this. Check it. Is it matching?
It was 394 and I thought it was 344. So I got 2579.
Okay. That is just
Same thing, 15 to 6 300. So I got 2579.
okay. So next question. These questions are very easy. This type of question you have done surely.
The first question where the graph was presented
Hmm.
are those type of question asked in net.
In net especially. Because in net you have 4 marks question, na? So in that section, yeah.
They confused by the plus minus.
Mm, No, basically these kind of questions are if you done one problem, na, then from next time you will not be confused anymore. For sure. Okay.
Yes.
That the first time when you are doing, probably you can make mistake. You see, I have also done. Because in general, theta is given, theta is shown, everything is given. You just want to put the values and get an answer. Get an answer. But and surely If just they want to calculate the daily each part, no, then obviously they will give the, let's say the answer was what, no, minus something 980. Let's say plus option will also be there. So, and you will just take the plus and you will get -1 negative marking. Okay. So
Yes.
these type of negative markings are very oftenly happen in the exam, especially in CSI net exam. So this is the tips you can think like that when you have the option like let's say same numerical value but just plus and minus. If you see in the option, then be very very careful. Then please means if I approach this question when I will obtain the answer, let's say 900 minus 900, and if I put the minus 900, if I select from the options, now if I see there is option of plus 900, that essentially signifies it should strike that probably the plus option is also feasible. Okay, then you have to just think if there is any mistake or not. These things will gradually come when you give lots of sample tests, mock tests, like these things.
Okay.
But also after that, also some mistakes will be there. You can't ignore that. But you can reduce. These are called silly mistakes, and these mistakes were oftenly done by me till now. Okay, so now one more. Wait, I think this type of question you have done before.
Yes.
Solve and give the correct answer. Try to give. Okay, let me start. Uh, Degree of dissociation alpha, that is 50%, means half is dissociated, right? So the reaction is Yes. So let's say we started with uh, okay, it's already given that 1 mole. This is in mole. It was 0, 0. Now, at what point they are asking, then n will be half. Correct?
And this is half and half.
Exactly. So total moles
3/2.
3/2. Correct. Now we have to calculate the K, Kp. Kp is the property of the equilibrium, so it is P of PCl5. No,
PCl3 and PCl2 by
PCl2.
PCl5.
So this is the case. So what is the PCl5? PCl5 will be the total pressure into the mole fraction.
Yes.
It is also, is it clear? And you see, all has the same mole fraction. And
Yes.
only one P will be survived. Correct?
P equals to 3 Kp.
Now it's already there. This is the answer.
Yes.
Mentioning. Okay, next question. Okay, 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 okay. Now these KPs are given. Right. What equation you should use?
ln k2 by k1 equals to del h naught by 2.303 r into 1 by t1 minus 1 by t2.
Exactly, the hand of equation.
Yes.
What is the entire equation? We have already calculated, right? Right. Okay. From here you can calculate. It is. So you can write it. Is it clear?
Yes. The answer is coming very less.
Very less.
Yes.
Okay, let me check. What is R? 8.31 K2 by K1. That will be essentially unitless. It is 9.1 divided by 20.2. And this is T1, T2. T1 is this. T2 is, sorry, no, is correct, correct. Kelvin. So it is. And T1,
1338.
yes. And the difference is 120.
Yes.
So calculate it. What are you getting?
4.88 into 10 to the power minus 4
No,
with minus sign.
let me check. So it is
Sorry, I have divided it.
1.45. This Boolean value essentially gives minus 0.7974. It will be joule. So make it 2 and make it kilojoule. Okay, kilojoule per mole. So it is, and make it 79, and it will be gone.
minus 90.035.
Exactly. 026. Yeah, that's 02. That's it. So this is the answer. This is our daily chart. Okay, so now what example we can solve from the phase part. Let me let me check whether you reminds or not. Okay. For a pure substance, the triple point in a phase diagram has how many number of degrees of freedom? One, two, zero, three.
0,
Why?
because I cannot handle anything. It's fixed pressure and in volume.
That's correct. But what is the logic?
The calculation.
Means how you can assure that? Because
It is connected to the three phase. Yes,
this
this is
this is the reason. Pure substance, correct? So C is one. P is
3.
that's the reason. Maybe I think you can do it. Okay, do it because this question you was complimentary to you. What are the components and the number of degrees of freedom?
This question is so confusing.
Don't worry, we'll solve in the extra class this type of question more.
The hydrogen is solid.
That is given. I don't know. Do it for this. That's why I also check twice whether it is solid. Maybe typo.
Phase is 3.
It is
3
why.
because there is 3 solid. I can identify them.
Oh, and gas?
Gas I cannot identify. I cannot see.
No, no, you can't see that means that is not phase. How you can say this? For each solid, you have to consider a separate phase. But for each gas, you don't need to be. Let's say air. In air, there are lots of gas, but that essentially signify a phase, gas phase. Okay.
Okay, phase is 4.
But it is given 3, so it is essentially the gas. Now the components.
Components 2,
2.
2 solid,
Components how you can define. C minus R, right? C was C prime minus R.
minus R, 3 minus 1,
Okay, one mistake I have done. So this is actually this. So essentially it is 4 minus 1, 3. Correct?
yes,
Constituents are 4 and one restriction, equilibrium restriction. So it is 4 minus 1, 3. And so what is the degree of freedom? C minus
C
P
minus
was
P plus 2,
2, C was 3, and P was again 3. So it is 2. Now we can you give it? I'm just asking, I'm writing this question. Sulfur can exist in 4 phases. This we have already discussed, right?
yes,
Two solid phase was there, rhombic sulfur and monoclinic sulfur, and gaseous and liquid phase. So sulfur can exist in 4 phases. The possible number of triple point was
4 C3,
4C3. What is the answer?
4,
Oh, no.
yes, the answer is 3, but it could be 4 because one is hypothetical.
That's the catch. So if you ask the possible number of triple point, then you have to say 4. But if you have asked the feasible number of triple point, then your answer will be 3. 4 is allowed,
Okay,
but that is a hypothetical. One of them is a hypothetical. Metastable triple point. Like
yes,
metastable state we had discussed now, that this is just like a metastable triple point. So these things we have to be careful. So now this we have discussed. These questions are very straightforward. I'm not asking. Okay, so today we can stop. I have to find more question. Next class, I will try to make some this miscellaneous question from all parts of this thermodynamics, whatever we have studied. Okay, from the basic this phase rule, this thermochemistry, then fugacity, these all parts, from all parts. Maybe from each part one or two question I will I'll select, and that question we can discuss in the next class. Okay.
the whole content.
Yes, because essentially that is the last class, and in extra class we have already mentioned that our plan is to discuss the Gibbs-Helmholtz equation and the rule function coefficient. And if you have any other doubts, that we can cover in the last class. That means in extra class, which will be in the 15th. And but in next class we will do
Okay,
just the numerical question or conceptual question from the entire course, and if possible, I'm not sure, if possible, then I can summarize the course if it is needed. Okay.
it is better if it happen.
Ha. The thermodynamic part we can summarize. That I will definitely summarize thermodynamic part. But these phase rule, these things, these I think these are the separate things. Is connected to thermodynamics, but the first law, second, and the third law, yes, I forgot. Third law, I'll just state. It is the third law, I will state. The third law we have not discussed. Just the statement and the equation that we should. Residual entropy part, you know.
Yes.
The third law you have not discussed. That I discussed definitely. Then briefly, more or less will be covered. Hope so. So, if you have any doubt, you can ask. Otherwise,
How to identify the component and phase?
that I have already said you how to identify. You have to practice lots of examples. Then you can do. Components you
Sol-
just constituents you can just calculate and then subtract the restriction. You will get the component. Phase is very clear. For all gaseous species, it will one phase. If the liquids are miscible, then it is a one phase. If it is immiscible, then a different phase. For each solid, it's a different phase. That's it.
okay, that I was asking.
That's it. Okay.
And the component I have to check.
Component, because you have to find out the restriction. That is crucial. C prime you can calculate. That the mistakes generally occurred in calculating the R part. Then degree of freedom is trivial to calculate. Nothing. Okay. So
Okay.
let me stop presenting where can okay. Okay. So thank you for joining. We'll again meet in the next class and that will be our officially last class. And again 15. Probably 15 is a holiday, so I think no problem will be there.
Okay.
You can join. Oh,
Okay.
okay.
Thank you.
So okay. Thanks for joining.